From the wheels on a car to the orbits of planets, circular geometry is essential for understanding motion and area. Today, we will master how to calculate sector areas using the most natural unit of measurement, the radian. While degrees are familiar, radians simplify our calculations. A radian is defined by the radius of the circle itself. When the arc length along the edge equals the radius, the angle formed is exactly 1 radian. In a full rotation of 360 degrees, there are exactly 2 pi radians. This relationship allows us to convert any degree measurement into radians by multiplying by pi over 180, setting the stage for easier area formulas. The formula for the area of a sector is 1/2 times the radius squared times the angle theta. This elegant formula only works when theta is measured in radians, making our geometric calculations much faster than using degrees. To understand why this formula works, remember that a sector is just a fraction of the whole circle. The ratio of the sector's angle to the full 2 pi rotation is the same as the ratio of the sector's area to the total area. Don't confuse arc length with area. Arc length, S, measures the distance along the curve, while area measures the space inside. Both rely on the radius and the radian angle, but the area involves squaring the radius. Because the radius is squared in our formula, doubling the radius of a sector actually quadruples its area. This exponential growth is a key feature of circular geometry that is important to visualize. Let's try an example. Given a radius of 6 centimeters and an angle of pi over 3 radians, we plug the values into our formula. Half of 36 is 18, and 18 times pi over 3 gives us an area of 6 pi square centimeters. If your angle is in degrees, convert it first. For a 90-degree sector with a radius of 10, we convert 90 degrees to pi over 2 radians. Then, half of 100 times pi over 2 results in an area of 25 pi. We can also work backward. If you know the area and the angle, you can solve for the radius. By rearranging the formula, we isolate r squared, take the square root, and find the distance from the center to the edge. Even with very small radian angles, the formula remains consistent. For a 20-meter radius and a 0.1 radian angle, the area is 20 square meters. Radians make these precise engineering calculations very straightforward. The most common mistake is forgetting to convert degrees to radians. Always ensure your angle is in the correct unit before squaring your radius, or your final area will be significantly overestimated. To summarize, circular geometry is streamlined by using radians. The arc length is simply radius times theta, and the sector area is 1/2 radius squared times theta. These two formulas are the foundation of circular measurement. Remember, always convert to radians first, square the radius for area calculations, and treat the sector as a proportional slice of the total circle. Mastery of these steps makes complex geometry simple. Here is a quick challenge: find the area of a sector with a radius of 4 and an angle of pi over 2. Squaring 4 gives 16, half of that is 8. Multiplying 8 by pi over 2 gives a final area of 4 pi. You are now ready to apply radian-based geometry to any circular problem. Whether in physics, engineering, or pure math, these tools are essential. Thank you for watching this lesson, generated by Vision Solve AI.